Hello there, welcome to this lecture. Let us begin studying car acceptability and predict its purchasability based on KNN classifier. It is going to be a fun. So first thing is we are going to give a good name to our notebook and we will call it KNN classifier. Okay, and next very quickly we are going to import all the required libraries. Import numpy as np, import pandas as pd, import cpon, import matplot. And next we are going to import the data. Based on previous lecture, you understand the data and I hope you have stored it on your computer. Now we are going to import that data to a data frame. And the command for that is, this is my data frame name, df pd dot read csv and then r and then give your file name over here. The file name is car.data. File does not have any header, so we will call header as none. Delimiter in the file is comma, and then we are going to give names to the column, that is names to the attributes, and the names going to be right here: buying, maintenance, door, luggage, boot, safety, cars. Okay, df dot hit, let's run it. Very good. So we got our data in data frame, and over here the next thing is we're going to see the shape of the data. How big is our data? 1728 rows and 7 columns. Very good. And the car over here is our target variable, and there are 1 2 3 4 5 6 independent variables. So as you see here, these are all categorical variables. We need to convert them to numerical variables. And how to do that? You already know it. It's called encoding. So we are going to do label encoding. So first we're going to import from sklearn dot pre-processing, import label encoder, and then we are going to encode each of these fields. So df buying equal to, before that we have to create an instance of label encoder, right? It's a class, so it needs an instance to be created first. And here, okay, so lbc dot fit underscore transform and df likewise we do the same thing for other fields. D int, then next one is going to be doors, then persons, then luggage boot, safety, car is a target variable, so we are not going to encode that. And let's print now df dot head. Very good, all are encoded now. So far so good. If you want to see the unique values in car target variable, it's a very easy. You can just run this line of code df car and just say unique. These are the unique values in these target variables. So your cars are going to be segregated among unacceptable, low, medium, high acceptability, acceptable, very good and good, right? You have to segregate, that is group cars among these 7 types of acceptability. So there are about 1728 records. You have to predict these classifications. On future data, if you have these 6 attributes available of the car, you should be able to predict whether it is among one of these 7 category of car. Okay, so let's move on. We have encoded this, so we are going to make sure whether all of these 6 feature values are numeric values now. So let's do that. df dot apply map np dot is real dot head. Okay, so true, 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 true and false. This is expected. We did not encode car, so it will be false. But all the feature values are true. So all the features are numeric values now. Very good. It's time to define our x and y. So let's say x equal to df dot drop. What is that we are dropping? Car, because that's a target variable. And y equal to df car. Good. So we have defined our x and y. Next we are going to define our training data set. From sklearn dot model selection import train test split. Good. Now x train, x test, y train, y test equals train test split x y test size. As usual, we will do 20% text size and random state going to be 0. Very good. Awesome. So far so good. Next, before we actually call the KNN classifier and pass this train and test data to that classifier, we need to find out the optimal value of K. Remember, we did this exercise during the KNN regression. We have to do the same thing to find out the optimal value of K, which you can use here. Let's do that. I am going to say here find optimum value of K. So let's begin. From sklearn dot neighbors import K neighbors classifier. From math import sqrt square root. From sklearn dot matrix import mean squared error. Very good. Let's begin. I'm going to say y1 equal to lbc dot fit transform. This we need to do because for this k calculation, even the target variables has to be encoded. It cannot be a categorical variable. So that's why I'm going to do the label encoding for the car target variable also. Okay, so that's my label encoded. And next I'm going to create one empty np array RMSC, and let's start for k in range 20, k equals k plus 1. You already did that. If you want, you can copy and paste from the previous program, previous notebook, that is KNN regression notebook. You can open and copy from there. So I'm going to create a instance of KNeighbor class. Here you go. So that's a instance now of KNeighbor class, and when we create the instance, we have to pass the neighbor number. Remember, over here we're going to pass it as k, and now knn dot fit, we're going to pass x and y1, and let's calculate the root mean square error. We're going to append the value to this one here. This is required in case you want to plot a graph. If you don't want to plot a graph, then you don't need to put the values to this empty array. But let's do that. Mean squared error y1, then knn dot predict, and we're going to pass x value here. So that is our empty array. Now let's print that. Print k value, and that's going to be our k value here, and then RMSC value. And that's going to be this guy. Not bad. Okay, and let's see if we got it right. Very good. Let's see. So it is either 7 or 8. So at 8 it is lowest, and then it keeps increasing after that. 1 looks anomalous, so I'm going to forget about that. Let's start with value 7. So we got the KNN value. So let's train our data model now. KNN is going to be k neighbors classifier, and n neighbors is going to be 7. Very good. And then knn dot fit, and we're going to pass our x train and y train. Awesome. So once you got our data model fit on the training data set, we are ready to predict. So ypred is going to be knn dot predict x test value. Good job. Now let's measure the accuracy of our model. From sklearn import metrics, and then let's print the accuracy. Accuracy score y, and then knn predict and x. Good job. Very good. We got accuracy of 93%. 93% accuracy on KNN classifier algorithm. You should be proud of yourself. Very good. Let us plot y value, the actual value, and y predicted value, and confirm how close they are. So to plot it, the first thing we have to do is first we have to convert both x and y in array. Currently x and y is pandas data frame. Let's convert them to np array now. Okay, so this will convert x and y to np array. Very good. Now that you have converted them to array, we can start plotting them. So let's say for x e y e in zip x y plt dot scatter xe ye into length of xe. Let's plot this much first. It's going to take some time because it's going to plot a scatter plot for each point of xe and ye. Very good. Let's make it little bit fancier. Marker is going to be O and size going to be no size, S is for size going to be 100. Let's do that. Let's do one more thing. Let's put color. These are our original values, so let's, as we have followed in previous lecture, let's give it color as blue. Good job. Now we're going to print the predicted values. So these are real x and y values, right? Now we're going to print the predicted values. So we will say for x, and instead of y it is going to be here knn predict and y, and rest out is going to be same, and here we will say hello, and instead of O we will say star, and we're going to reduce the size to 10 so that it plots on top of the actual value, and then we will say plt dot show. Awesome. It's going to take some time. Here you go. See yellow star, those are predicted values, and the blue dot, those are actual values, and you see predicted values on top of each actual value. So that's working fine. Only for low there is no predicted values. For all other cases it is predicting perfectly fine, and that's why you got this accuracy of 93%. So I have a homework for you. What happened with the low value? Why the prediction was not there for the low value? Just look at the data and think. You will find the answer. I'm waiting for your answer. Please message me. I will see you in next lecture.